discuss about forces in all aspects. I'll let it go with the flow. You could actually tell me if you need any clarifications. So when we discuss about types of forces, these are things we already have discussed. Frictional force. This person is moving in this direction, right? So how does the frictional force act in the opposite direction? In fact, that is what is keeping this person stable. Gravitational force pulling this person down. Magnetic force, which you are not using now. Applied force. So you apply a force pushing a trolley. You're pushing a trolley, you're applying a force in this direction. Buoyant force, which is acting upwards. Tension force. So these two teams are playing tug of war. So there's a tension this side, there is also a tension this side. Obviously, they have to be equal. Drag force, trying to acting upwards. Spring force, also called you could equate it to elastic force. The potential energy that is stored comes as force. These are the types of forces. We'll be seeing it as and when we discuss. So mechanically, when we are discussing about forces, these are the types we'll be discussing: coplanar and non-coplanar. So coplanar in the same plane. So you have, let us say, a system of x and y. If there are two forces like this, you say they are coplanar, right? Suppose you have a z-axis as well. You have this second thing somewhere here. They are non-coplanar. They are in different planes. Collinear along the same line. Collinear is along the same line. So let us assume two forces acting this way. They are parallel also. Not this is not collinear. I'm sorry. Let us assume two people standing and playing tug of war, both acting like this. It is a collinear force. So there are people opposite also pulling the string. This is also collinear. Here it will be F1 plus F2. Here it will be F1 plus F2 is equal to F3 plus F4. They are also collinear, though they are acting in opposite directions. So what is a concurrent force? Concurrent forces are those which are acting towards the same point. For example, let me say I have this xy axis. I have different forces towards or away from the same point. The center of focus is only this. This is a concurrent force. A non-concurrent force will not act towards the same point. I'll come to it later on. Then we have parallel. Parallel is two people, let us say, pushing a car, working in the same direction. Parallel force. Non-concurrent, non-parallel. You may have non-concurrent is you can have non-concurrent and parallel. So you have a block here, right? There is a support here. There is a support here also. It is non-concurrent because the forces are acting at two different places, but they are parallel. You could have non-concurrent, non-parallel also, and I'm not going to the examples now, right? Non-parallel is force like, okay, if you want this here, I may have something hanging here. So they are both are acting here. They are non-concurrent. They are also not parallel. Non-coplanar in different planes. There also you could have in different planes concurrent, parallel, and non-concurrent, non-parallel. Since I told you what each of these mean, we will see these as and when we go. Okay, right. So now I have a problem given here. I am asked to find out this F. So equilibrium of forces. When you speak about equilibrium of forces, a force, you have a system of forces that is in equilibrium when the uh, forces balance each other. There is no net force. So here, which means you can have a system of horizontal forces. So which means sigma h, horizontal forces, or let me call it sigma fh. Sum of horizontal forces will have to be 0. Similarly, the sum of vertical forces also for a system has to be 0, then this system, else the sum of all these, the entire system also should evaluate to be 0, else. Okay. When you resolve horizontal and vertical force, the resultant also could be 0. Either these can be separately 0, or the resultant, when you resolve them, this could also be 0. Now let us take a very simple case. You have two forces acting upwards, one force acting downwards. You should know this value. This is the simplest. So you will have F minus 200 minus, sorry, 250, right? Minus 250 minus 400 is equal to 0. Why? F is acting downwards. This 250 Newton and 400 Newtons are acting upwards. So F minus 250 minus 400 is equal to 0. So what will you have? F to 650 Newtons. This is the simplest. A case of vertical forces which are equal to each other. Now, equilibrium of forces. So I have three forces here. I have labeled them F1, F2, F3. So this will also be in order theta 1, theta 2 and theta 3. So I should have a scenario where sigma h, FH has to be 0. And also sigma FH I had to find out. I also have to find out sigma FV, which is the vertical force. So if I have to find out sigma FH, it is F1 cos theta 1, F2 cos theta 2 plus F3 cos theta 3. Why? Because having a force like this is my horizontal component, this is theta, and this will give you my vertical component. Am I right? So if this is force, my horizontal component is got from F cos theta. How's my vertical component got? F sin theta. So having this in mind, let us go and solve this problem. Okay, what is my F1? My F1 is 200 Newton into cos 45. Okay. Now what is my F2? F2 is 600 Newton into cos 60. Now comes my F3. Remember, we are speaking about vectors. So both F1 and F2 are in the positive x direction. What about F3? F3 is in the negative x direction. So what should I be writing? I should be writing F3 as minus 400 cos 30. Clear? So what will I get? I should be getting 95.01 Newton. I had already worked out, so I'm straight writing this value. Then sigma FV vertical. F1 sine 45. Now, what is F2? F2 is in the minus y direction. So what will I have? I'll have minus 600 sine 60. What about F3? F3 is in the positive y direction. So I will have 400 sine 30. That evaluates to be minus 178.2 Newton. So I have found out F1 and F2. So the resultant force is a triangular law, right? So I have found out FH. I have found out FV. So this will give me my resultant, right? Resultant R. Resultant is given by sigma FH square plus sigma FV square. So what is the value I get? The value I get is 201.95 newtons. You can work it. Now let us take a free body diagram case and also the equilibrium of forces and determine the values here. Okay. So this is a case of, this is in the same plane as you can see, and also concurrent forces acting towards this point. Everything is acting in the same point. So we have to resolve the vertical and the horizontal components. So let us see what are the forces acting on this sphere. So if you take this sphere, what are the forces? Vertical forces, if you want, this is a force that is acting downwards, that is pulling it downwards. This is 100. And there is a force that is acting upwards. So if you take this as an axis, there is a force that is acting upwards but at an angle. If you can see, this is acting. So this is at an angle. Similarly, you can, so sorry. You can also draw a vertical here. So if this is theta, this is also going to be theta. So let me say this is going to be theta, and here theta is given as 15 degree. This is acting upwards. These are the two vertical forces. Do I have any other vertical force? I don't. What is the only force that is acting horizontally? This normal force. How is it acting? Along this direction. So this is the horizontal force that is acting along this. But remember, this is in equilibrium, else this horizontal force will swing the sphere. So there is a horizontal force also exerted by this tension which is acting in the opposite direction. Now you'll have to resolve this into two components, in the vertical and the horizontal component. So forming a triangle, this being the adjacent side, the vertical force is given by the cos component, the horizontal component is given by the sine component. So for the horizontal component, this is your reaction force R, and here the tension force T. You have two unknowns which you have to solve for. So for the horizontal component, I will say for FH, I will have R, right? Let us say R minus T sine theta is equal to 0. Sine 15, right? I can replace this theta by 15. So what will I have here? R is equal to T sine 15. This is my from my horizontal component. What about my vertical force? So I have 100 here. So I can say T cos 15 minus 100 is equal to 0. Or what will I have? T cos 15 is equal to 100. Or I could say T is equal to 100 by cos 15, and this value works out to be 103.52 newtons, which means this tension is 103.52 newtons, which I could now substitute here, right? So what do I have here? I have R is equal to 103.52 into sine 15. So my R now works out to be 26.8 newtons. So this is how you solve problems using free body diagram and also the force.